Okay, so we'll start off with some common Arizona soils. There are many soil types found in Arizona, besides obviously tropical soils, and these soils have lots of clay, resulting in higher alkalinity. In Arizona, there is iron present in the soil. However, the alkalinity of the soil prevents the plants from actually absorbing it. So many plants grown in alkaline soil suffer from iron deficiency, resulting in what's called yellow foliage, which is pictured over here on the left. These clay soils have the potential to expand greatly in volume when wet and to collapse drastically when hot and dry, which can be a problem for plants and for buildings as well. These soils can also be low in nutrients and difficult to work with, which requires the addition of organic matter. The problem, only 1% of Arizona soil content is organic matter, and organic matter is what helps the soil hold water and nutrients. Um, and these soils are separated into layers. According to the Arizona Cooperative Extension, most soils have two or more distinct layers. They're also called soil horizons. Um, these layers include the surface soil, the subsurface, and the subsoil. And so all that organic matter is stored in the surface layer, which is why the plant roots obtain their nutrients and their water from that layer. But these layers, they differ in color, texture, consistency, and structure, as well as chemical characteristics and composition. So caliche, it's a very common throughout Arizona. It's found beneath the surface layer of the soil. It occurs in the subsoil. This layer of soil can be up to 6 feet deep. The particles in caliche are essentially cemented together with calcium carbonate, and it's hardened natural cement of calcium carbonate that binds other materials like gravel, sand, clay, and silt. And roots cannot penetrate caliche, and water also cannot move through it. So any serious digging requires a jackhammer. Very tough to dig through. And Casa Grande is the most common soil type throughout Arizona. It's the state soil of Arizona. The properties are that it is very deep, well drained, saline sodic soil. The surfaces comprise old alluvium, which is when clay, silt, sand, and gravel are deposited down flowing streams from surrounding mountains. This soil can be very productive with a little bit of irrigation to help wash out salts, but intensive management is necessary to reduce the impacts of the salts. Otherwise, the soils will not be productive.
All right, I'm going to be going over the type of soil testing. The field tech will be out on a job site, say a new land development job, and uh, he'll go grab a bag of soil, and he'll bring it back to the lab to do a soil compaction test to gain a proctor. Um, and essentially, what they're going to be doing is adding some water to the soil, putting it into this proctor mold, and they're going to do it in two stages, or referred to as two lifts. They're going to take this proctor hammer, they're going to hammer it down for like 15 times each stage, and then basically they're going to be able to compare the dry unit weight to find the optimum moisture for the soil, at which point there will be a significant drop off in the bell curve once it reaches optimal moisture. Each soil type, like say sand, is not going to be able to absorb as much moisture as when you compare it to say something expansive like clay. All right, and then we're going to go over compaction testing. The field tech's going to be using something referred to as a nuclear. It's like a nuke gauge. They're going to put a plate down, and they're going to hammer a pin. It's going to create a hole, probably about 12 inches deep. They're going to then move that away. They're going to take the nuke gauge, put it over the hole, and slide the rod into the ground, and it's basically gonna give them an accurate reading on the data when it comes to dry density and moisture content. That when and they can compare that data to the proctor to see how much or how close or how far off they are within that range. The goal is usually to kind of get 95% compaction. So if it's not up to that standard, then he'll basically refer to the heavy equipment crew and let them know that they need to keep adding water and keep working the soil until it gets to that 95%. All right, so next we'll be going over expansive soils. Clays expand. They tend to swell a lot when it comes to moisture. They lock it in, and then when it dries out, it shrinks a lot. So with this expanding and shrinking, it causes havoc on things such as concrete. It also can cause a lot of uplift in the soil, and also can create sinkholes. And the reason it's so critical that you want to compact the soil to 95% per se for this example is to help mitigate any of these issues, so that your surface soil is ready to be building on, and you're going to have less issues going way down the road.
Okay, so I'll be talking about the hard dig. Hard digs are usually when the excavation cannot be done by the regular equipment, shovels and dozers, and that's due to hard rock or caliche that's under the surface. Usually it's unexpected. You most of the time wouldn't want to willfully go into a hard dig, but it is possible. And so I have prepared an example of what a hard dig might look like, and then some information about hard digs. So on to the next slide. Here's an example of what a hard dig might look like. This is a pool. Perfect. So that video shows how that machine was cutting through the rock and breaking up that rock that couldn't be moved by the typical dozers or a shovel or anything like that. That rock was way too hard to be moved and had to be broken up. And that's why hard digs they cost more time. It requires different equipment and more money. And so usually, when it comes to a hard dig, it goes as far as the people are willing to pay. So if you're not willing to pay the money that requires a hard dig, then that dig won't get done, or you'll have to change location or whatever the deal is. So ideally, you would go into it with knowing what the soil is, but unfortunately in Arizona, that's a problem here. A lot of times when people are, in this case, digging a swimming pool, they run into that hard rock or caliche that prevents them from going as deep or where they need to go. So that would require a hard dig where we're bringing this heavier equipment and different people, which costs time, energy, and resources. So that essentially is what a hard dig is. And, it's possible with the equipment that we have, but is less convenient than just a regular dig.
Now I'm going to be talking about the Caterpillar D10 dozer, also known as the Cat D10. The only other dozer larger than this in the Caterpillar world is the D11. The dozer is a crucial piece of heavy equipment for excavation and grading. Currently, multiple D8s, D9s, and D10s are being used to grade the large Taiwanese microchip plant in North Phoenix. There are two main tools attached to both the front of the dozer and the rear of the dozer. To push the dirt on the operator uses the front of the dozer. It's called the blade. At the rear of the dozer, we have a ripper shank with a tooth. This is used to cut through the material, much like a heavy-duty knife, and loosen the material for scrapers or excavators. This is especially useful for hard digs discussed earlier in the presentation. The ripper can go through rock and other hard materials such as caliche. Some material is so hard, even a skilled operator can only make the thick steel tooth last only a couple hours. Here's a video of a dozer ripping through some hard material. It may appear easy to operate a dozer in the video, but it's much harder than it looks. An experienced operator is essential to production during a job. A few problems that can accrue from an unexperienced operator not using the dozer efficiently, so there will not be material readily available for the scrapers to pick up and move. Also, an unexperienced operator could easily overheat the idlers and rollers and cause some serious damage to the dozer and its tracks. The type of material is very important to take into consideration when bidding a job. For example, if the job has a large amount of caliche and rock, a sole D9 or a D10 may be devoted to ripping before, during, and after shift. On the other hand, if the majority of the site is moist topsoil, only 1 or 2 D8s may be needed to push material. Thank you for enjoying our presentation on Arizona soils and excavation.